Okay, kids, this is the conclusion of the last example that I was working in section 1.3 of multiplying polynomials together, where I ran out of tape. So apparently when I said that I'm going to have short lectures, it's just not going to happen with Algebra 2. But here you see that you've got a binomial times a trinomial. And when you have this sort of a setup, well, you could go ahead and, that pen doesn't work here at the library. Let's see if this one works. That one doesn't work. Maybe the green one will work. Nope, the green one doesn't work. So I'm going to have to go back to one of these blue ones that I brought. Okay. We could go ahead and multiply out horizontally, but I think that's a little bit confusing and it can get to where you have a really big, long, messy string. Instead, we set it up so that we can multiply this problem vertically in a similar manner to the way that you do just regular old division. We would set 9a squared plus 4a minus 7 would be the initial factor in our product. Because it has 3 terms, we're going to put it at the top. Then we're going to follow with times 6a minus 2. And this is a multiplication problem. Okay, multiplying. We're going to work this out very similarly to the way that you would do a traditional multiplication problem. You can do this 2 separate ways. You can multiply beginning at the right and move towards the left. You can multiply beginning at the left and move towards the right. Let me show you both ways and you determine for yourself which you prefer. Remember that your sign goes along with the term. So here we have negative 2 times a negative 7. Negative times negative is a positive 14. Negative 2 times a positive 4a. Negative times positive gives you a negative 8a. Negative 2 times a positive 9a squared. Negative 2 times positive 9 is negative 18. Then you simply have the a squared. And that's all of the multiplication that you have, where you've taken this negative 2 and you've factored it, you've multiplied it against each one of those 3 terms. Now we have to take 6a times negative 7 times 4a times 9a squared. Similarly to how, if this were 62, you would take the units times the problem, then you would take the tens times the problem. Now we're going to multiply 6a, it's positive, times a negative 7. 6 times a negative 7 is negative 42a. We're going to line up negative 42a. See? 6 times 4, both of those are positive, so it's positive 24. A times a, remember what happens when you multiply exponentials that have the same base? You simply add the exponents. You have a to the first times a to the first, or a times a is a squared. And you see that we have already an a squared, so our a's are lined up, our squares are lined up, our constant terms are lined up, even there's only one little partial product right there that equals 14. So now our last one, 6 times 9 is 54, and it's positive. Now we have a times a squared. What do you have there? Same base, add the exponent. The base is a, 2 plus 1 is 3. And you notice we put it over on this side because now we have a cubed. There are no other a cubes. Now we're simply going to add these 2 partial products together. 54a cubed, 54a cubed. Negative 18 plus 24, when you have different signs that you're adding, you subtract the smaller number from the larger number. It's actually the absolute value, but you don't have to think in that complicated of a fashion. You say 24 minus 18 is 6, and we're going to use the sign that is in front of this larger number here, the larger absolute value. So it's 24 is larger. So that becomes plus 6a squared. Negative 8 minus 42. You're already negative 8. You go 42 further negative, minus 50. And here, it's 50a. It's not 50a squared. It's 50a squared. It's not 50a to the 4th, because we're not multiplying 18a squared and 24a squared. We're adding. And when you add like terms, just like 18 apples, 24 apples, you don't have apples squared or apples times apples. So when you're adding like terms, you simply add the coefficients. Negative 8 plus a negative 42 is a negative 50, and then you use your variable, negative 50a plus 14. And that right there is your solution. And if we look here in the book, which I'm not sure what happened to that page, 54a cubed plus 6a squared minus 50a plus 14. It'd be pretty bad if I didn't get it right. Now this was how you do the multiplication, moving from right to left. Now let's see if we can do it in a slightly different fashion. And see what you think about this. Maybe you say, okay, well, I'm used to reading right to left. Let's see what I can do. Okay, negative 2 times a positive 9a squared. Negative 2 times positive 9. Negative 18a squared. Negative 2 times a positive 4a becomes a negative 8a. Negative times negative becomes a positive 17, positive 14. I can just make my tongue cooperate. Now I have to multiply 6a times 9a squared. 6 times 9 is 54, a cubed. Because I have a times a squared, keep the base, add the exponents. 54a cubed, 6a times a positive 4a. Positive 6 times positive 4 is positive 24. A times a is a squared. 6a times the negative 7. 6 times the negative 7 is a negative 42a, and there's nothing else to multiply. Now we combine these two partial products. 54a cubed, negative 18 plus 24, same as we had last time, plus 6a squared minus 50a plus 14. That's all there is to multiplying binomials, trinomials, polynomials in a vertical fashion. But since this is still pretty new to you, be careful that you remember that when you're multiplying exponentials, when you're multiplying, when you have factors, you're going to keep the base and add the exponents, which is how we ended up with 54a cubed. However, when you're adding common terms, when you're combining common terms, you simply add together, combine together those coefficients, and you keep the variable part just as it is, a squared. So that's the rest of section 1.3.